Okay, guys, welcome to the second lab. And in this lab, our objective is basically to practice programming of arithmetic operations in assembly language. Okay, so the required hardware is you just need Arduino Uno board and you need the USB cable for charging and data transmission to and from the board, right? So let me first walk you through the part A, and part B and part C are you have to do them. They are like a task for you to do, and I will walk you through the part A. Okay, so first of all, download these two files, lab2.ini and add.s. I have already downloaded them. They are in my download directory. So then in the next step, what you need to do is just go ahead and open your Arduino IDE. So when you see when you open the Arduino IDE, you will see an initial sketch is created. So what you need to do is that go to your download directory. So for example, I'm going to my download directory and looking for lab file. Yes, this one, and open it with any text editor. So I'm opening it with text edit, and I'm copying all the all the stuff from this file, and then I'm going to my Arduino and selecting all of its content, deleting it, and then pasting what I copied from the downloaded file. And after that, go ahead and save this file as lab2. I'm going to save it in my course directory with name of lab2. Okay. Okay. So, okay. After that, the next thing you need to do is that you remember you also had to download the second file add.s. So simply go to your download directory and copy the file and paste it in the directory where you have saved your lab. So for me, it is in the course directory labs lab2. So I'm here pasting the add.s file, right? When I do so and I go back to Arduino IDE, so I will see that another tab here is opened with the name of add.s, right? So these are the like steps. So in this video now we have done the step 1, step 2, step 3, 4, yeah, and step 4, 4 and 5, 5 and 6, right? So now let's go to the step 7. So step 7 is basically before going to the step 7, let me first explain what we are going to do in part A of this lab. So basically we are going to we are going to burn a program in the AVR microcontroller on the Uno board, and this program is going to do the following things. First, it will 1A, so it will do step 1A, where it will first read three numbers, for example, three two-digit numbers, decimal numbers. So for example, uh, if I provide an input of 05 through my laptop, it will be read, and then on my microcontroller, the 05 will be saved in a variable x1. Then the program will ask me, remember the program is running on the AVR microcontroller, but we are communicating with our laptop through the USB port, right? So when I say that program asks me to enter a two-digit number, so on my console in the serial monitor, which I will show you later, within the Arduino IDE, the program running in AVR microcontroller will display a prompt saying that, okay, enter a two-digit number. So if I enter 05, that will be saved in the variable x1 in data memory of AVR microcontroller. Then it will ask me to enter another number, two-digit number. So let's say if I enter 30, then it will be saved in the variable x2 in data memory of the AVR microcontroller. Then AVR microcontroller will send another message to my laptop saying, okay, enter of another two-digit number, 32-digit number. So let's say this time I enter 15, so it will be saved in the variable x3 in data memory of the microcontroller. After that, Our program will do the addition of the three numbers x1 plus x2 plus x3 and save it in the variable x3. So if with these particular values of x1, x2, and x3, the result of summation will be 50. And once that, after performing the addition, our AVR microcontroller will send an output which will be displayed on the in the Arduino in the serial monitor of Arduino IDE, and it will say, okay, after addition. So it will just first send this string after addition, and then it will send another string. The value is 50. So we will see this output on our laptop within the Arduino IDE, in the serial monitor component of the Arduino IDE. Okay. So let's first just run the code to demonstrate that it is working fine, and then I will explain the code itself. Okay. So to do that, first what you need to do is that you need to go to the Arduino IDE again, and then from the tools, make sure that you have selected the correct Arduino board, Arduino Uno. Also, again from the tools menu, go and select, make sure that you have connected your Arduino board with through the you have selected the correct port here. So my port is not appearing here because USB port is not serial port is not appearing here because I have not yet connected my board. So I'm going to connect it first. Okay, and now if I go to tools and go to the port, so here now I see USB serial port is connected, selected, right? So make sure you make the right selections. Okay, so after doing that, the next thing you need to do is that you need to so next thing you need to do is that you need to select this amplify button, which will open the serial monitor window, right? So when you click, so you will see here a serial monitor window is opened. And after doing that, you also need to select from this drop down option, drop down list, the option of no line ending. And from here, you need to select 9600 baud. Okay. So at this time point, don't worry about what is the meaning of 9600 baud, because the purpose of this lab is not to understand how the serial communication or serial port or of AVR microcontroller works. The purpose of this lab is to do the arithmetic operations. Later on, when we will study the serial communication of AVR microcontroller, then you will know what is the meaning of 9600 baud. At this time, you can just say that it means basically you are saying that my laptop will communicate with the AVR microcontroller at a bit rate of 9600 bits per second. So the bits are transferred from AVR microcontroller to the laptop, and from laptop to the AVR microcontroller at a speed of 9600 bits per second, right? Okay. So after doing that, next thing you need to do is that you need to go to this arrow button within a circle which says upload and press it. So it will compile your program or your sketch and also download or write the binary into the program memory. Once it is written, it is now asking you enter a two-digit decimal value, right? Let's say I enter 05. Then it says, okay, enter another two-digit decimal file value. Let's say I enter 30. It's asking me for the third decimal value. Let's say I enter 15 this time. So then it says the value entered is 15, and after addition, the value is 50. Okay. So this is the uh, output of the program, right? From here, from this option, you can actually also clear the output if you want, right? So now, with this, now let's go to the code and see what our code is doing here. Let's start from our lab2.ini file, which basically which basically shows the code written in a C-like format, a C-like syntax. So first, we are saying here, the first line here is saying that extern byte x1, x2, x3. So basically, here we are telling that in this file, we are going to use three variables, each are of a byte size, x1, x2, and 3. But these variables are external to this file, which means that they are not defined in this file, but they are defined in some other file. So don't worry, you can look into some other files and you will find them. So this is basically what we are telling the Arduino IDE. Then we are also telling extern C void addition void. So what we are saying here is that we have also defined a function with name of addition in some other file. It is not defined in this file, but we are using it in this file. So don't worry, you can look into some other file to find this addition, right? So basically, we will define these variables x1, x2, x3, and the function addition in the assembly file. We will look into the assembly file in a little bit, but let's continue with our uh, data in the file. For now, I'm skipping this read two-digit value. So let's first go to the setup function, right? So in the setup function, you are first saying serial dot begin 9600. So actually, you are saying that the laptop will communicate with the AVR and AVR will communicate with both will communicate with each other using a bit rate of 9600 bits per second. Okay. After that, we want to read three numbers from the user, and for reading the one number to one two-digit number, we need to invoke this function read two-digit value at a time. So I will go into detail of this function in a bit, but for time being, let's continue. So we are reading two-digit number. Let's say I entered 05, so it will be saved in X1. Then I'm calling the function again. So again, we will read two-digit number. It will be saved in X2. And third time again, when we call the function, and another third two-bit number is read and saved in the X3. So from where it is read from the keyboard, and it goes uh, to the variable x3, which is in the data memory of AVR microcontroller, right? Then in the program which we have burned in the microcontroller, it performs the addition of these three numbers, and it puts the result in the x3, and then it sends this message, a string, to the laptop, which is displayed in the serial monitor of the Arduino IDE saying after addition here. And then it prints another and then it also, after saying after addition, it starts new line, because here we are saying serial dot print ln new line, right? And then it prints another string, the value is, right? And then it prints the x3 in decimal format. So here we are saying that it is show it in decimal format, and here we are giving the type of the variable. So here we are saying print it as an integer, right? So this is how our program is working, right? Now let's go uh, to this read two-digit value function, right? So let's see how it is working. Okay, before going there, let's also have a look at the loop. Remember, as I said, and as we said, looked in the first lab, that setup function is invoked only once, and after that, the loop function is invoked repeatedly forever, right? So what we are doing here is that we are simply saying, okay, wait for 20,000 milliseconds or 20 seconds basically, and then we are saying after waiting, print an static on a line, and then again keep doing same, again wait for 20 seconds and then print a static symbol and keep doing forever, right? Now uh, okay, let's continue from the same point. So now let's go to this read two-digit value function, right? And look into the body of that function. So here, what we are saying is that in the body of this function, the first line says that it declares two variable inch of type byte and a val or value of type integer, right? And then you are saying serial dot println enter a two-digit number. So this is basically the way how we communicate with the serial port of the AVR microcontroller. But as I said, this is not the focus of today's lab. So you just ignore this part for the time being, right? Uh, because it is not the focus of the lab. We will have separate lecture on the serial communication, and then it will be clear for you how data is sent. But Arduino IDE provides you the how to say built-in statements where you don't need to understand the assembly, and you can simply write this statement just to uh, if you want your AVR microcontroller to send this statement, enter a two-digit decimal value to your laptop through the USB port, right? And then we are saying after printing this statement, so your AVR microcontroller will print this statement on the laptop, and then it will check whether the serial port is available or not. And if not, it will wait for 100 for 100 time units, and then it will then uh, it will read a value. When I say it, basically the microcontroller will read a value from the laptop. So it first sends the message to the laptop that, okay, enter a two-digit decimal value. Then user enters a two-digit value. So that those digits are transferred, uh, how to say, symbol by symbol. So for example, if you write the value 05, so let me just comment here. So if you, let's say, on your keyboard you enter the value 05, so it will be transferred as two different symbols, 0 and 5. So when it will transferred as symbols, so actually the ASCII of that number will be transferred, right? So then what we are doing is that we are actually breaking down that number. So let me pause here. I will be back. Just give me I will back. I just want to open the ASCII table so that I can explain the things. Okay. Okay. Now let's first have a look at this ASCII table from our lecture slides. So if you look at the character on the ASCII table, we have here character 0, right? So the ASCII of the character 0 is 30. And then for example, you have uh, character 1, 2, 3, 4, 5 up to 9, right? And their ASCII codes are increasing from 31, 32 up to 39, right? So remember that that the now if I go back to the, let me go back to the Arduino code. So here if I am entering 05, so basically what happens is that when I send 05, so basically uh, the send 05. So first the ASCII of 0 is sent. So what is ASCII of 0? So ASCII of 0 is let me let me check from the slides. So ASCII of 0 is 30, right? So what we are saying, so ASCII of 0 is sent, which is 0x30. So now in the next statement, we are saying, okay, so when we send 05, so first only 0 is sent, right? So 0x30 is ASCII of character 0, right? So first the ASCII of character 0 is sent, right? And then in the next statement, which is received then on the microcontroller side, after receiving it, what does the microcontroller do is that it saves it in the inch. So actually the value of inch becomes equal to 0x30, right? So then in the next statement, we are subtracting the note here. We are putting here we are writing 0 within single quotation marks, right? So basically we are saying subtract from inch the ASCII of character 0. So inch is already equal to 0x30, and the ASCII of 0 is also 0x30. So we get 0 as a result of subtraction, and then we multiply it with 10. So it will be equal to uh, 0, right? So the value is equal to 0 here, right? And then we are saying, okay, in the next statement, we are saying, okay, wait again, check if the serial port is available for the communication or not. If serial port is not available for communication, wait for 100 time units, right? Or 100. Okay. And after that, we are saying, okay, again, read a character. Remember that if as a user I enter 05 on the serial monitor of the Arduino IDE, so the 0 is sent as a character and then 5 is sent as a character. So we in these previous statements here, we have taken care of reading the character 0. Now we are going to take care of reading the next character, which is 5, right? So uh, here we receive the ASCII of the next character, which is 5. So we are saying that inch becomes equal to ASCII of character 5, which is 0x35, right? And then in the next statement, we are saying that first subtract from inch the ASCII value of inch, the ASCII code of 0, right? So basically, we are saying inch is equal to 0x35 minus 0x30. So it is equal to 0x05, which is equal to decimal 5, right? So, and then we save this value in the val variable. So what was val previously? It was 0. So 0 plus 5 becomes 5. So since we entered 05, so it is converted. So we entered two-digit number 05, but then it is converted into a into absolute value of 5, right? Through these different statements, which I have just explained. Okay, and then in the next statement, the AVR microcontroller is sending this string. The value entered is to the to our laptop through the USB port, right? Through the USB cable. So this string will be printed, and after that, the value of the so AVR microcontroller sends the string to laptop through USB cable, which is then received by Arduino IDE and displayed in its serial monitor, right? And here again, the AVR microcontroller, let me just start, microcontroller sends the value of val variable, which is 5, to laptop, which is displayed in serial monitor using base, using decimal system, right? And then it also not and it also returns this function read two-digit value. This function also returns the value of the variable val to its caller. So who is the caller? The setup function was the caller, and then the control comes back to this line number 47, right? So basically it means that now x1 will get the value of val, which was 5, right? So then for reading the second variable x2, we again call the same function read two-digit value, right? So and the same process happens again, right? And the whatever value is taken or entered by the by a user through the keyboard is stored in the x2 variable in the data memory of the microcontroller, and then we read the third variable from the keyboard and store it in the x3 variable of the data memory of microcontroller, right? And once we are done with that, we call the function addition, right? Now, where is this function addition defined, or even where this x1, x2, and x3, where are these variable declared? They are declared in the add.s file. Now, let's have a look at the add.s file. So in this add.s file, we have first we have some comments. So we are just saying that we are defining the global data x1, x2, and x3. What does it mean? So let me walk you through through the assembly file line by line. At line number 5, we are saying, so first three lines are comments, like these 2 to 5 are comments, and then on the line 5 we are saying dot data. Dot data is not an assembly instruction, it is a directive for the assembler. So actually we are telling assembler that whatever we are going to put after line 5, treat it as a data and put it is in the data memory of the microcontroller. So when you will convert this program into the binary file, and when you will load that file into the memory of the microcontroller, so put this section, all of this section, in the data memory of the microcontroller, right? And then in the next line, we are saying .com x11. Basically, here we are saying, let me comment it. Put everything find below, but before .text directive in data memory of the microcontroller. Then in the next line, we again have a directive .com. So here com stands for common, right? And just like in C, C++, or Java, you have, when you want, let's say that in a file you have multiple functions, and then you want to have a variable which you want to be visible in all the functions. So you define it as a global variable. So what is the meaning of global variable, global visibility? In the C, we achieve the same visibility for a variable in a file by defining sorry, by using the directive x. So what we are saying is that I am declaring a variable x1, and it is of size 1 byte. So that's why I'm putting a 1 here after the comma, and make it visible to all the code in this file, right? Declare a variable of size 1 byte and make it visible to all the code contained in this file. Sorry. Declare a variable. Let's say, let me give it a name x1. Okay. Then in the next directive, dot global. So dot global is same as we uh, want to make a variable visible to the other files in a C language, right? So here we are actually in the .com tells that, okay, make this variable visible to all the code in this file. But when we say dot global x1, we are saying make this variable x1 visible to the code in other files of the same sketch, and also in the other files of the same project, for example, lab2.ino, right? So make this variable x1 visible to the code or program defined in other files of the same sketch. So basically we want now x1, now the x1 will become visible also in lab2.ino, and that's why we will be able to write put a value now x1 in lab2.ino file, right? And then we do the same thing for same thing for, why it is putting a dot, don't put the dot. Okay, so then we are doing the same thing with the variable x2 uh, and x3. Okay, so if you want, I can simply copy paste the comments and declare a variable x2, declare a variable x3, and make variable x2 visible to other files and make variable x3 visible to the code defined in other files. Now, after that, we are starting our program section. So this is just a command. So program section actually starts with .text directive. So this directive actually tells the assembler to put whatever is written below in the code memory of microcontroller, right? And here we are saying that, okay, we are going to define a label with the name of edition, and we want it to be global. Global mean we want it also to become visible to the code in other files. We make label edition visible to other files in the same sketch. So it will become visible in the lab2 data, and that's why we will be able to call this function addition from the lab2 data file. But this function itself is defined in the assembly file. So here, this is just a label for function addition, right? And so what we are doing here is that uh, we are saying, okay, uh, first load direct from the static RAM. So LDS stands for LDS is load direct from static RAM or SRAM, right? So actually we are saying that since remember we have already defined X1 in the data memory. And where is the data memory? Data memory is actually yes in static RAM. It is a static RAM, right? On the same chip, on the same microcontroller chip, right? So we are saying so whatever the value of that memory location is, right? We have defined this variable x1, right? So we are saying, so actually after, let me go back. So after this dot com x1 and dot com x2 and dot com x3, so what happens that, let me show on the notepad. So what happens is like you have so let's say this is your data memory, right? So you ask .com x1, it actually reserved 1 byte of data and named it as x1. Let's say your memory starts at address, I'm just making up some number. Let's say 0xF0. This is not exact correct address where the actually memory starts, but I'm just making up some number to explain the things, right? So when you say .com x1, so 1 byte is reserved and it is given a name x1. Now when you say .com x2 1, so another byte is reserved and it is given the name x2. And when you say .com x3 1, so another byte is reserved and it is given the name x3, right? Now, since these bytes are reserved and they are named, so you can address these memory locations by their name. Like instead of specifying the address of those memory locations, you can just say, you can just specify their name in your code like x1, x2, and x3. So this is just like you actually have variables or create variables in the C language, right? So here that's why we are saying in this instruction load direct from static RAM. Load, so if we are loading something from the static RAM, which is data RAM, so which is data memory, so we need to provide the address, right? So the address is we are providing it as x1 because we have reserved that memory location and we have already given it a name, so we don't need to know its address. We can simply say x1, right? So we are saying that, okay, uh, actually we are saying that move the data in R18 register from memory location, our data memory location, whose address is x1, right? And then in the next statement, we are doing the same thing. We are basically saying load direct from static RAM and load the data in the register R19 and put it, load the data from memory data memory location x2 and put it in the R19 register. And in the next statement, we are saying that read the value from data memory from location x3 and put it in the R20 register, right? And after that, we are saying, okay, now what we have in R18, we have x1, in R19, we have x2, and in R20, we have x3. So in next statement, we are doing the summation of uh, R18 and 19. So we are saying R18 is equal to R18 plus R19, which is basically we are saying, which is same as x1 is equal to x1 plus x2, right? And then in next statement, we are saying R18 is equal to R18 plus R20, which is same as x1 is equal to x1 plus x3. And then we are saying, okay, now STS stands for store to static RAM. So we are basically saying that, okay, put the value of x3 in the, put the value of R18 in the memory address, data memory location at x3, put the value of R18, right? So remember, R18 is now equal to what? It is equal to x1 plus x2, because remember we have already here added x1 plus x2 and then added x3 to it. So it becomes equal to x1 plus x2 plus x3, right? So now this is the way how we have added all the three numbers and put the result back in the memory in variable x3. And then we are saying, okay, return, which means return execution back to the caller. So who was caller of this lab2.inso, right? So we come here. So at this point, after we come after completing the addition function, so we have the result of the three inputs which were entered by the user as variable x1, x2, and x3. We have their summation available in the variable x3 in the memory, right? So after that, we are uh, we are executing the statement serial.println after evaluations, after addition. So actually, microcontroller will send this statement, this string after addition to laptop to USB, and which will be displayed on serial monitor, right? And then when this next statement will be executed by microcontroller, so the microcontroller is essentially send this string, the value is to laptop through USB, and then this will also be displayed. And then in next, the microcontroller will send value of x3 variable to laptop through USB, which will be also displayed on serial monitor in decimal format. So we want the serial monitor to display it in the decimal format. Okay. So this is how our our code is working. Okay. Now I think I have clearly explained the part A of the lab. Now let's go to the part B, right? Okay, so in part B, what you need to do is that you need to modify your addition function in the assembly file and add.s file, right? So here, this originally this assembly file is, sorry, I need to change language. Okay, so following code is implementing x3 is equal to x1 plus x2 plus x3, right? So in part B, you need to modify this assembly file such that you can implement uh, uh, this equation like x3 is equal to 2 times of x1 plus 1, which is then added to x2 minus 1, which is then added to x3 minus 3. And remember that when you want to do this computation, do not use the multiply instruction, right? So in order to multiply here, for example, 2 times, what you can do is that you can add the number twice to itself, right? So then it means you are multiplying it with 2. So what you can do is that you can first increment x1 by 1 and then add it to itself. So it's mean you will be done with this part, right? You can decrement x2 by 1, and here you can decrement x3 by 3, right? And then you can add together x1, x2, and x3 and put the result back in x3, right? Now, I have said that in order to multiply, you can simply add a number to itself when you want to multiply it with 2, right? And for increment and decrement, you use these two instructions, increment and decrement. So when you say increment R16, so here you are saying that increase the value, whatever value of R16 you have, increase it by 1 and put it back in the R16. So let's say if the value of the R16 was 7, let's say it was 1. So after increment, R16 will become 2. Similarly, decrement decreases the value of a register with by 1. So let's say if the value of the of register R16 was 10, after decrement R16 it will become 9, right? So you can use these increment and decrement instructions to implement this equation, right? So also when you are modifying your code, what you can do is like you can simply just to make sure that you you want to keep the original code, you can simply comment all of it here, and then here, for example, you can have implement part B, right? And then you can test it, right? So in this way, your uh, previous code, which was implementing the part A, will not interfere, or whenever you want to revert back to it, you can revert back, right? Uh, Now the part C, in the part C, what you need to do is that after doing the addition operation, you have to turn on an LED, right? So so here, after doing the addition and before returning, you need to implement part C, which is turn on and turn on the LED on. Let me check which pin is this. In on port B, pin 5 of the microcontroller. So how you can do that, let me show you it here. So it is actually explained in the lab description. So what you need to do is that first you need to set the uh, pin number. Let me count. Pin number 13 on the AVR on the Arduino board. So let me go back to the Arduino board here. Maybe we can go to lab 1 if we can see. Can I zoom it? Yeah. Okay, let me go to lab 2, I guess it will be more clear. So here, uh, what? So here you have these pins like 0, 1, 2, 3 up to up to pin number 13. So LED is connected with pin 13. So actually this pin 13 is the pin number 5 on port B of the microcontroller. Remember in the first lecture I explained the pin mapping between the AVR microcontroller and the Arduino board. So pin 13 is actually the pin 5 on port B, right? So we need to first configure the pin 5 of port B into output mode. Remember that the port pins can be used both as as an input pin or as an output pin, but we need to first configure. So first we need to configure it as an output port, and then after that we can turn on the LED to indicate that addition is completed, right? After that, after performing the addition. So how can we do that? For that, what you can do is that you can put first these two instructions in your assembly code. So what you are saying here, let me do it here in the, so I'm simply copying it here. So here what I'm saying is that in this instruction I'm saying that load 0x20 in R18 register, right? And then I'm saying that write R18 register to address 0x04, which is address of the port direction register for port B. Remember that we have 8 pins in the port B, and here we are saying, okay, write 0x20. The 0x20 is equal to this binary. So here we are saying that set all the uh, pins of the set the direction of all the pins of the port as input pins other than the pin at bit location number uh, bit number 6, right? You can count from this side, from the least significant 0, 1, 2, 3, 4, 5. Actually bit number 5. Okay, so which corresponds to bit number 13 on your Arduino board, right? So here we are simply first uh, next two statements configure the Arduino pin 13, which is port B pin 5 as output pin, right? And then after configuring it, we need to write a 1 on the pin so that the LED which is connected with the pin is turned on, right? So for that, we can add these two instructions. So here we are saying load value of 0x20 in register R18, and then we are saying write R18 to address 0x05, which is address of the output register for port B, right? So now if we write the value of 0x05, so then it means that that value will be displayed uh, here, starting, so 0 bit will be displayed. Let me draw it if I can. So 0 bit will be displayed here, bit 0, bit 1, bit 2, bit 3, bit 4, and bit 5 will be displayed here. Remember, bit 5 is 1 and all other bits are 0. So all of these will be zeros, but bit here we will have bit 1 written. And now this pin is connected with LED, so LED will turn on when we write 1, right? So here, these two next two statements, write logic 1 on pin 13 of Arduino, which is output, which is port B5 output pin. Okay. So I have not in this in this video, I have not implemented part B. You need to do it on your own, but I have implemented part C. And definitely you have to do it also in the lab. Now I'm going to again, how to say, uh, again I'm going to compile my program and load it, and then we will see that if the LED turns on or not on the yeah, if the LED is turned on or not on my microcontroller. One thing which we can do is, like, if our LED is on by default on the board, so we can turn it off first. So in the setup function, so after setting the baud rate, you can add these two lines, which will actually make sure that our LED is turned off, right? So we are actually doing the same thing which we did in assembly, but now this time we are doing it in the Arduino style. So in the C type, a C like syntax. Okay. So here I'm saying, okay, let me put the comment. Make sure that LED on pin 13 of Arduino board is turned off initially, right? Now I can compile my program and load it on the Uno board. Okay, so let's say I enter 05, then I enter 30, then I enter 15. Okay, let me reset and see if my LED is turning on or not. 5, 30. Oh, sorry, let me reset. 05, 30, 15. Let me reset again. 05, I'm just testing. 20, 15. Yeah, and LED turns on, but it don't stays on forever. I am not sure why it is happening. Uh, Yeah, I'm not sure why it is. Let me fix it, and then I will show you. Uh, okay, so actually I was looking at the wrong LED. So now you can see that the LED is there are two LEDs on the board. One is red and one is green. So the green one is one which is turned on after the addition. So to verify, I can show you again. So if I reset my, let me first clean the serial monitor and then reset. Now I'm entering the numbers. The LED is off. The green LED is still off, and now you can see the green LED has turned on. Okay, so this is the way how you can implement the part C. Okay, so with that, I will stop the video and I will share it with the recording with you. So good luck with the lab.